evening, everyone. My name is Paul, and it's good to be back in Chippy. Good to be back talking. Welcome to the June 2024 main meeting. And again, my name is Paul Breo. About me, I've been a member since the mid 2000s. Long time. But first and foremost, I want to thank Chippy because and the Python community in general, because I don't know if you've been to other meetups like JavaScript or Ruby or anything like that, but our community intentionally welcomes people from different places, and it's apparent in our code of conduct, right? I'm sure others have had that, but it's first and foremost. Another thing is that programmers are not necessarily known for being necessarily good public speakers, but we because of this place, it's a safe space to developers. And so I'll tell you a story about myself. So as I mentioned, I've been here since mid 2010s, and very shy in public speaking, but this place allows me to come here and to give talks like this. And so for anyone that's new here, you joined a special community. Welcome. So I worked in C# for my day job and just doing a startup. We can talk about that later. I work in Python for my personal projects. Worked in Django, and in 2021 I gave a talk about machine learning, and I gave specific at the time speculations, and they've actually come true. So that's kind of given me the impetus to give a follow-up here. And I'll be posting the talk as well as resources on my website here. The agenda for this talk is I'll recap briefly the talk that I gave in 2021, the status quo, and then my proposed solutions, as well as the luckily or unluckily my predictions panned out, or not panned out, but they unfolded as I predicted, and then my proposed upgrade, for lack of a better word, moving forwards, which is hierarchical PGMs. More on that later. So stepping back. Stepping back to biology. So I've thought a lot about this, and really you can delineate intelligence as the old brain and the new brain. What I mean by that is like the old brain, like being like the lizard brain, like the lizard, like what I mean by that is like stimulus response, or like so more concretely, like when you're walking down the street and it's cold, like you automatically shiver. That's like that. Those are automatic responses. That's what I mean by old brain. Currently, we're using that method of quote unquote intelligence. So what I mean by that is like, okay, so like if you've studied machine learning, I'm not gonna get too much into it, but basically you throw tons of data at it, and then it's a stimulus response mechanism. That's the old brain. as I mentioned, requires a lot of training data. No, there's really no thought when you're shivering. There's no thought. You just shiver, right? So there's no model. There's no actual model of the world. Low generalization. What I mean by that is that since, well, I'm not going to get too much into that. Now, talking about the new brain. So back to the example of when you're walking down the street and you're thinking about work. That's the new brain working. Like you're worried. Like now you have like a simulation of your brain, of your head. It's like, oh no, I gotta worry about this deployment or that deployment, this bug or that bug. So that's a new brain. It has a causal model of the world. You know, was my wife gonna yell at me? Is my boyfriend gonna yell at me? So that's what I mean by a new brain. So it's a high generalization. What I mean by high generalization, I mean, you know, I've learned to model the world, so now I can tell stories about it. I can write poetry. I can do all sorts of things. That's what I mean by generalization. It's not, you're not really particularly focused on, you know, surviving a cold weather. Now you have more options at play. Okay, so enough about that. In my original talk, I gave the limitations, as I mentioned before. Limit one would be requiring massive amounts of data. The solution to that would be assumptions. I'm not going to get too much into that. But TLDR, assumptions meaning like, well, I don't want to get too much away. I'm not going to get too much away about assumptions. But well, we know in computer science that when you're making an algorithm, you want to speed up an algorithm. You add in assumptions, right? Example, like if you want to speed up a recursive recursive algorithm, you add memoization. So you add some sort of thing like that. As I mentioned before, the old brain has no causal model of the real world. My solution to that was to add memory, senses, and imagination. So briefly, memory, I mean like, okay, I've seen this before. I've seen what happened before. So now at least in my mental simulation or imagination, I can see what's going to happen next, right? And it doesn't have to be as complicated. It doesn't have to be as sophisticated as that. But it's an example that we're all pretty familiar with. I mean, you can go all the way down to like your dog, or to a human being, you know. But you could say that they have some sort of form of memory. Senses, imagination. All these three things together, they kind of infer you need some sort of embodiment, right? Like you can't have senses if you don't have like some sort of embodiment, right? And that's enough about that. So it's a summary, just to put a bow on it. You need imagination. So here's Ronald McDonald on surfing. You have your senses and your memory. Okay. So that's a recap of my previous talk. So now let's go back to the current architecture. So it's actually, as I mentioned before, I've been thinking a lot about this, and it's actually, well, if the beauty of the internet is like if you really want to, if you want to deep dive into something, you'll be able to find it. So just an example, and I'm not picking on any particular person. Just an example. There was a 60 Minutes actually did this great compilation where they published their investigation on the current LLM technology, particularly Google, and two particular segments stuck out at me. One was they were asking the CEO. I mean, he wasn't hiding anything. He was saying he admitted, like, yeah, there's a particular aspect of it which is the black box, right? There's like you have these gigantic pools of data with billions of parameters, right? A parameter is basically just a variable, and it's connected. I'm not going to get too much into it, but so he admitted that. So the second, it's hard to believe, but it is what it is. The second fact that they presented was that it's a black box, and you can't always rely on it. So it hallucinates. So okay, example. So they asked the reporter Leslie Stahl. They asked the Googler, like, okay, can you tell me what it knows about me? And so they asked Leslie Stahl, and it spits out like her biography. Like, and the first thing it says, like, it worked for CBS. Like, she's like, I never worked for CBS. I never worked for NBC, rather. Like, so, yeah. So that's the reality of it, you know. Black box. It's a black box, and it hallucinates. To put another fine point on it is that one of the thought leaders even admits to this, like the then head of Tesla AI, Karpathy, says that in his presentation, it admits it's a black box. Okay, so I mean, as I mentioned before, you throw tons of data at it, and yes, you get this behavior, you get this complexity, quadratic complexity. I propose this blue line where we have imagination, you know. Yeah, okay. I don't want to make enemies. All right. So I want to step back. I want to say the current technology right now is pretty effing amazing. You know. You know. So I'll tell you a story. So I started writing a book, and I have a tendency to like hand wring, but like with using the model, the current technology, I use Gemini. You can use whatever you want. I say, okay, write me a draft. And so it gives you ideas, right? So at least it gets the ball rolling, you know. So it's in that sense, it's very good. So drafting, editing, summarizing text, that's awesome, you know, especially for people that like are perfectionists like me. Simple code generation. It's a lightning rod. So I'm not going to talk about them, but it's a lightning. But it's okay. Another story. I was playing around with 3GS because I wanted to make a visualization for like for something for my website, and I could have Googled it, but like 3GS just gives me the tutorial. I mean, the Gemini just gives me the tutorial. It's like I don't have time to Google it. Just give me the tutorial, and so it does. And if you prompt it good enough, it'll give you a tutorial. Like, okay, it's not gonna be perfect because I mean you still have to like copy and paste the code and actually test it, you know. but at least it gives you it saves a lot of time, for lack of a better word. If you're curious, yeah, you can just I mean you can Google it and you can explore it, but like it's like an oracle, like it's like literally it's like okay, you can say example. You go to ChatGPT, you say okay, pretend that you're Socrates, and tell me all about the ethical concerns of blah blah blah, whatever. You just tell it. You tell it how to behave, and it'll converse with you. It's pretty cool. So ML is good, but it can be better. All right. So in the interest of time, I'm just gonna focus on explainability, right? Um, yeah, I mean, briefly, human-aligned, requiring a lot less data and affordable to all. That's beyond the scope of this talk. So actually, how many people have some familiarity with ANNs, artificial neural networks? How many people? Okay, so there's some familiar. Okay, so we know that I'm not gonna get too deep into it because that might be beyond the scope of this. We know ANNs, like as I said before, and the thought leaders have admitted it, it's a black box. So there's another architecture where you look at nature as a hierarchy, right? So in this case, I'm just gonna say, so we start with words. I mean, you can go to however deep level you go, but in this case, I'm just gonna go with words, sentences, paragraphs, chapters, books, right? And you can use that for magazines or whatever. But in this case, I'm just gonna use this example of words to books. It's a hierarchy, right? You can think of anything in nature, whether it be molecules, cells, whatever. But and I'm just gonna let's just stick with this. So that's my axiom that the world we live in it can be broken down into hierarchies. So the next step is now that assuming that the axiom, now we can now we can form a relationship among the hierarchy into a tree. So let's say we lump the words into sentences, into paragraphs, into chapters, and then finally a book, right? Stepping back, let me just briefly discuss graph theory. All it is okay. Let me actually make it simpler. All this chart is saying is that the circles are the concepts or the things. The lines give some sort of relationship, and the lines you can assign numerical values to those relationships. Let me give you a concrete example. So I mentioned this. So it's a hierarchical PG. Okay, so yeah, so that's the important lesson here, or the important concept I'm trying to put is instead of artificial neural networks, we're gonna I propose something we can actually see from all the way down from the littlest pixel to the actual book. or however you want to make the window. Use hierarchical PGMs. So I'm going to end this talk with an example. So here this is just a simple example where I have three nodes, three words at the bottom, and its parent node is a sentence. So as I mentioned before, a node represents some sort of concept, right? It whether the concept be a pixel, a color, or whatever, but the key point is that it's gonna form that layer forms a group, and then on top of that group is gonna be another concept or meta concept, right? In the interest of time, I'm not gonna belabor that point, but back to the example. So the girl ate is a simple sentence, and now you can have many different permutations of this sentence. But let me go back to this thing. Yes, it's gonna be a lot. It's gonna be a lot. But it's not gonna behave quadratically, right? It's gonna be a lot because there's a lot of variations, but there's only so many variations. I mean, our language has rules, right? That's why it's gonna taper off, you know. And so that's the concept. That's the concept. And by the way, these edges there should be gonna be numbers here, or here, or anywhere here. But I'm just simplify it. The point of the mathematics behind it is going to be a relationship. And so how does that help us understand? That's the whole point of it. The whole point of pooling it is to understand it, right? The whole point of the ANN is to you feed it some sort of input, and then it's going to categorize it for you. How does this method do the same thing? How does feeding it an input allow you to categorize it? Well, in this case, I'm going to feed it a particular sentence, and you can change the nodes to whatever you want to, and then assign the parent node, associate the parent node with some other categories. I'm not gonna, again, in this time, I'm not gonna give you the whole steps, but I hope that's clear. All right. So as a recap, LLMs are awesome, but they're not perfect. I mean, they're awesome, but they're not perfect. And I propose upgrading it to this architecture. If you want some resources, this is the link. I highly recommend 3 Blue 1 Brown. I mean, he recently came out with LLM series. In my opinion, it's superb. It's like for being free, I'm like, damn, I've learned a lot. And then so a big shout out to the scientists that have taught me a lot about this. Dilip George, he was the one. So Dilip George actually, Dilip George, Scott Phoenix, and Hawkins. Hawkins was a former. He invented the co-invented the Palm Pilot. So there's some very very insightful individuals, very insightful lessons. I recommend watching these podcasts. And with that, again, thank you, Chippy, and hope this was helpful. Thank you. I should do, Heather, do we have any time for questions? Or? Okay, cool. Let me just go up this. I guess have any questions or anything like that?
Hello. Hey, so first of all, I want to commend you. It's not easy to get in front of a lot of people and give a talk about something, so I think that was fantastic. So I commend you for that. I want to ask you a question about, so a big assumption behind your theory is that black boxes, it's not good if something's a black box. And I'm assuming that you're not talking about the visibility, right? You're talking about the fact that it's difficult to interpret. I guess my question is, why is it necessarily a bad thing that it's difficult to interpret if the outcome is beneficial?
Great point. So I have some. So that's a great point. So I have some. I actually do have some friends in the industry where they have some clients in the insurance industry, for example. They want to use this technology to answer some of the questions. And they give them the answers from their models, but the client's like, can you just give us the old-fashioned way? Because they want to know, because it's a lot of money on the line. They want to know every single step. Another example. I have friends in radiology. You know, it's pretty cool that you can get diagnosis from a doctor that's tireless, that has But what if the diagnosis really like? How do you know the diagnosis is right? Can you give me it says remember I mentioned before, there's a hallucination, because there's always going to be that nagging part of wait, it says I might have cancer here or there, but do I really want to cut this person open to find out? So yeah, that's perfectly good question. It's a great question, as a matter of fact. So I hope that answers the question. Yeah.
So machine learning has had a explainability problem since after even, agent-based systems with like regular expert systems with but basically if-then conditionals, and then the move toward random forest. It is an active research topic to actually add explainability to a lot of ML systems. And I'm not sure how PGMs here are work. It seems like you're working with an ontology, but I don't see how, where is the PGM in this system?
Okay, so it's a fair point, because it's a fair point in term, because the example I used was kind of, okay, let me step back. There's this video by 3 Blue 1 Brown about talking about. I'm just gonna give context. He talks about. So I think when was it? I think it was in the was it in the 90s? So this thing before LLMs. So it's, even further back, before LLMs, there's this thing called perceptrons, right? How many of you guys have ever used the Palm Pilot? Remember the Palm Up? It had a graffiti, right? So that was kind of like ancillarily kind of based on the Perceptron, where like it has like, you know, you have like a gesture, and because based on the gesture, it gave you your it gave the symbol, right? From my understanding, the Perceptron was based on ANNs. I could be wrong. I could be wrong.
Perceptron by Minsky, the book, was showing that, like, given the basic form of artificial networks, that XOR could be expressed. Unclear if XOR was expressed, that was the thing that did discourage research in it because they couldn't have the XOR. They solved the XOR problem by adding hidden layers so that it could output.
Yeah. So, okay. So it looks like, sir, we're gonna talk because there's a lot of stuff. In the interest of time. So the point being is that I could have used images as showing every single probability leading to symbols and to such, you know, and there's a numerical value for each layer. Instead, I use words, right? It's kind of meta, and so I understand the confusion. So that's the confusion, but to answer your question, this has already been this PGM's already been validated by Dilip George, and how much time do we have? So that gives me it's a short way of saying that this is the right way of doing it. It's been done, and so I'm not proposing anything that hasn't been proven already nor productized. Is what I'm saying. Okay. So yes, sir, we can talk about the nitty gritty if you want to talk about the nitty gritty. But in the interest of time, yeah, that's the thing. So PG, okay. Long story short, the PGM's already been proven, and I'm just saying it to be more understandable. So I hope. All right. Thank you. Thanks again, guys.
Got it? All right, we're